So we defined the line integral. Now we're going to take a look at an example here. A wire takes the shape of a semicircle. The shape of semicircle, x squared plus y squared equals to 1, and y is positive. It means that you are looking at the wire here. This is your wire. The wire is thicker near its base than near the top. These are the pieces of information that we have. Thicker near its base than near the top. Okay, so we are interested in knowing what is the center of mass. What is the center of mass if the linear density, so we need some more information, for example, about F, if the linear density at any point is proportional to its distance, is proportional to its distance from the line y equals to 1. Very good. So we basically know that this is what we introduced before. M is equal to the line integral of rho ds along C. And the center of mass that we discussed before, x bar is equal to 1 over m line integral x rho of x and y ds, and y bar is equal to 1 over m line integral y rho of x and y ds. Perfect. So let us try to build rho. All right. We have these pieces of information. We know that at any point it is proportional to its distance from the line y equal to 1. So note that if it was y equals to 0, or if you had just x-axis, it would be just k, or the constant of proportionality. But now here you have line y equals to 1, which is going to be this line here. Y equals to 1. So rho is going to be equal to k times the distance, which is 1 minus y. Very good. Let us use x equals to cosine t and y equals to sine t. So of course t is bounded between 0 and pi, and ds is going to be square root of, as you saw before, dx dt is negative sine t to the second, plus here you have cosine t to the second and dt. So obviously ds is equal to dt. Let's find the mass first, mass of the wire. We need to find a formula for the mass. As we know, it's not homogeneous. it's different at different points. So your mass is equal to the integral of rho, which is k times 1 minus y. And here you have, well, let's see what we can do here, ds. Then we're going to just substitute this between 0 and pi. But for now, it is c. Then we're going to convert everything in t, and you're going to see that. So the mass is equal to the integral 0 to pi k times 1 minus y, which is sine t, and ds, which is dt. This guy is equal to, well, let's do the computation. We have k, and the integral of 1 is t, and here you have sine t, cosine t, 0 to pi. It becomes k times pi minus 1 minus 0, and here you have 1. So you get k times pi minus 2. So this is the mass. Now that you have the mass, you can easily find the center of the mass following the formula. X bar is equal to 1 over m, 1 divided by k times pi minus 2. And here you have the integral x, which is defined as cosine t, and just plug them all back here. Rho of x and y, which is defined as 1 minus y, or 1 minus sine t, and we know that ds and dt are the same thing, and do the computation. Just going back to elementary calculus. So your x bar is going to be equal to, let's do the computation here. Let's just move this up. Very good. 1 over k pi minus 2, and the integral of cosine, which is sine t. And here you have the integral of sine times cosine, which can be written as negative a half sine of 2t. So you get cosine of 2t, and it's going to be a plus 0 to pi. Very good. So this guy can be written. I'll try my best to have enough space to write everything down for you. Pi minus 2. So x bar is 1 divided by k pi minus 2. If I plug in 0 pi, it's going to be 0. But here I have a half. I get cosine of 2 pi minus cosine of 0, which is 0. So far my x coordinate is equal to 0. Let us find the y coordinate. My y coordinate is equal to 1 over m, k times pi minus 2, and the integral 0 to pi, and y, which is defined as sine t times 1 minus sine t dt. So if we do the computation here, it's equal to 1 over k times pi minus 2. And here you have the integral of sine, which is negative cosine. And here you have negative sine squared. Okay, you have negative sine squared, or just sine squared, which can be written as 1 minus cosine 2t divided by 2. And then you can just take the integral, and this integral is equal to negative t divided by 2 plus 1/4 sine of 2t, and then just plug in 0 and pi and do the computation. So y bar is equal to 1 over k pi minus 2. And here if I plug in pi, I get 1. And here you get pi over 2. This is going to be 0. Again, this is 0, and this is 0. So if we simplify this guy, here we get, let's see, 4 minus pi. So depends on what k is, how K is defined, we can actually find Y bar. So Y bar is equal to 4 minus pi divided by K times pi minus 2. If K, for example, is equal to 1, just for simplicity, if K is equal to 1, because it says proportional. When it says proportional, you define a constant like K. It might be a half. It can be just a positive number, am I right? So if K is equal to 1, for example, here, your X bar and Y bar is 0 and 4 minus pi divided by pi minus 2, which is approximately is going to be 0 and 0.38. So 0 and 0.38 is going to be your center of the mass here, almost here. This is the center of the mass. So we can use line integral and see one application to find the center of the mass of wire that has thickness different on top than any other points.